All right, for part B, this is a little bit more like what we've seen, just finding area. But this one's going to be a little bit different because we're finding the area of S. And what cut would fit this region best? Dx cut or dy cut? Dy cut, right? Because this line is always to the right of this graph. So dy cut would be the best fit. Problem is that we can't do that in this case. Alright, so for this one, this graph, remember, is y equals 4x squared minus x cubed. Can we solve this for x nicely? No. Right now with an x squared and x cubed in there, we can't like get x by itself without any x's on the other side. So we can't use a dy cut if we can't solve this equation for x. And then our line here is 18 minus 3x. So we can't use a dy cut. That would be the easier option if we could, but we can't. So what we're going to have to do for this one is break it up into two parts. We're going to look at this little region right here, and this little region right here. Right, we can find the area of each part separately and add them up to get the area of S. So we know this point right here is at 3, 9. And we're going to use dx cut for each of these because we have to. We can't use a dy cut. So for our first part, we're going to have the definite integral from 3 to what x value? Well, we don't know yet. We have to figure out where this graph crosses the x-axis. All right, we could graph this on our calculator and figure it out, but really this is not a tough one to do by hand. It'd probably take just as much time. If we set that equation, 4x squared minus x cubed equal to 0, factor out an x squared, oops, we get x squared times 4 minus x. So we get x equals 0 and x equals 4. So this graph, we can see, intersects at 0 here, and this is going to be at 4, 0. So we know this first area, the yellow region, is going to go from 3 to 4. Yeah.
When you solve that equation, is it ever when you get those two answers, is it ever not going to be those two answers?
No. All right. So now we're finding the area of the yellow region from 3 to 4. We're going to take the top function minus the bottom function. Right? So we've got the line, 18 minus 3x, minus the curve. We want to put that in parentheses, 4x squared minus x cubed. Plus definite integral from 4 to this point, wherever this line crosses the x-axis. So again, we could graph it and do it on our calculator, but this is pretty simple. We want to know when is 18 minus 3x equal to 0. Well, that happens when x is 6. So this is at 6, 0. So the second integral is going from 4 to 6. And if we're doing top minus bottom, we're doing the line minus the x-axis, which is really just 0. So really, all we're doing is finding the area under the curve or under the line. So it's just 18 minus 3x dx. Now this is a calculated part of the test, so this part I would do with the calculator since we can. This will be a little bit quicker. But before I put it in the calculator, I'm going to go ahead and distribute this minus, just so I don't have to deal with so many parentheses and everything. So we're going to do the definite integral from 3 to 4 of 18 minus 3x minus 4x squared plus x cubed dx plus definite integral from 4 to 6 of 18 minus 3x dx. And voila, I've already got it typed in there. We get 7.916 repeating. If you round it to 3 decimal places, that's fine, 7.917, but you can also write it as an exact answer, 95/12ths. Alright, so we end up with 7.917 or 95/12 is our answer.